This is a video from section 3.11. We're going to look at derivatives of inverse hyperbolic functions. We're going to start with number 1. The claim is that the derivative with respect to x of the inverse hyperbolic sine of x is equal to 1 over the square root of 1 plus x squared. Now, let's look at why that's true. Set y equal to inverse hyperbolic sine of x. So x is equal to hyperbolic sine of y. Now, what we want to do is we want to differentiate x equals hyperbolic sine of y with respect to x. So the derivative of x is 1. The derivative of the hyperbolic sine of y is hyperbolic cosine of y times, by the chain rule, we're going to have dy dx. But if I solve for dy dx, I get 1 over hyperbolic cosine of y. Now, remember, hyperbolic cosine squared of y minus hyperbolic sine squared y equals 1. So I'm going to solve for hyperbolic cosine squared y. So hyperbolic cosine squared y is 1 plus hyperbolic sine squared y. But remember, if I take hyperbolic cosine of y, that's always non-negative. Okay? Why? Because remember that hyperbolic cosine y is e to the y plus e to the negative y divided by 2. And you're adding up two exponentials that can never be negative. And so that means that the hyperbolic cosine of y can never be negative. Now, why is that important? Because I want to solve for hyperbolic cosine y, and I'm going to take the square root of 1 plus hyperbolic sine squared y. And so this, I could say this, dy dx is 1 over the square root of 1 plus hyperbolic sine squared y. Now, remember, x equals hyperbolic sine of y. So what I'm going to do is I'm going to replace hyperbolic sine of y with x. And so I can say, therefore, dy dx is 1 over the square root of 1 plus x squared. And so the derivative with respect to x of the inverse hyperbolic sine of x is 1 over the square root of 1 plus x squared. They're all derived in a very similar manner, by the way. Now, if we look at number 2, number 2 claims that the derivative with respect to x of the inverse hyperbolic cosine of x is 1 over the square root of x squared minus 1. Now, let's look at why this works. Set y equal to inverse hyperbolic cosine of x. Now, the interesting thing here is when I solve for x, I get hyperbolic cosine y, where y is greater than or equal to 0. So that's how we define that. And that'll be important in a minute. Now, at this line here, differentiate both sides with respect to x. So I get 1 is hyperbolic sine of y times dy dx. So therefore, dy dx is 1 over hyperbolic sine of y. Now, hyperbolic cosine squared of y, so let's write that down. Hyperbolic cosine squared y minus hyperbolic sine squared y is 1. So I can say that hyperbolic sine squared y is, here, let's create a little more room. So I can say hyperbolic sine squared y is hyperbolic cosine squared y minus 1. Now, remember that y is greater than or equal to 0, so this is always going to be greater than or equal to 1. And so when I take the square root, I get hyperbolic sine of y is the square root of hyperbolic cosine squared y minus 1. And so, therefore, dy dx is 1 over the square root of hyperbolic cosine squared y minus 1, but x equals hyperbolic cosine y. Therefore, dy dx is 1 over the square root of x squared minus 1. Thus, d dx of the inverse hyperbolic cosine x is 1 over the square root of x squared minus 1. And let's take a look at this one here, number 3, the derivative with respect to x of the inverse hyperbolic tangent of x. The claim is that that's 1 over 1 minus x squared. Now, same game, I'm going to set y equal to the inverse hyperbolic tangent of x. That says that x is hyperbolic tangent of y. Now, remember, you're differentiating with respect to x. And so I'm going to take the derivative of x with respect to x is 1. The derivative of hyperbolic tangent of y with respect to x is hyperbolic secant squared y times dy dx. So, dy dx is 1 over hyperbolic secant squared y. Now, the question is, how does hyperbolic secant of y relate to hyperbolic tangent of y? Now, let's go through this. So, I can't remember, so I start here. Hyperbolic cosine squared y minus hyperbolic sine squared y is 1. So I'm going to divide everything by hyperbolic cosine squared y. So 1 minus hyperbolic tangent squared y is hyperbolic secant squared y. Now, that says that dy dx is 1 over 1 minus hyperbolic tangent squared y. But remember, x equals hyperbolic tangent y. So therefore, dy dx is 1 over 1 minus x squared. Therefore, the derivative with respect to x of inverse hyperbolic tangent of x is 1 over 1 minus x squared. Now, with that in mind, we're going to look at some examples. Let's take a look at number 1. Suppose I had this one. Let's start here. Suppose y is the inverse hyperbolic tangent of x squared. And I want to know what the derivative is. So this is a great application of the chain rule. And we have the derivative of the inverse hyperbolic tangent up here. So instead of an x, it's an x squared. So I'm going to go 1 over 1 minus something squared, but inside that parentheses, I'm going to put that x squared. But by the chain rule, I have to multiply by the derivative of x squared. So if we simplify this a little bit, we get dy dx is 1 over 1 minus x to the fourth times 2x, right? So don't forget about the derivative of x squared is what's producing that 2x. And so this is 2x over 1 minus x to the fourth. And that's how you take the derivative. Let's take a look at this one, number 2. Suppose I had y equals inverse hyperbolic sine of negative 2x. Now, we want to know what dy dx is. So I look and go, let's go back. Right here. Okay? So if you notice, when I take the derivative of the inverse hyperbolic sine of x, I get 1 over the square root of 1 plus x squared. But instead of an x, I have negative 2x, right? So let's go back here. So I'm going to take 1 over the square root of 1 plus, so again, instead of an x, it's negative 2x. So I'm going to write negative 2x to the second power, but then I'm going to take the derivative, right? In other words, I'm going to multiply by the derivative of negative 2x. And so this is 1 over the square root of 1 plus 4x squared times negative 2. And so, therefore, dy dx is negative 2 over the square root of 1 plus 4x squared. And that's the answer to example 2. If we take a look at example 3, suppose I give you this one. Well, we'll do this one. Y equals x times inverse hyperbolic tangent of x plus natural log of the square root of 1 minus x squared. Okay. Now, if I want dy dx, so if we look at this first term, it's the product rule. Okay? So now, with the product rule, I'm going to write the derivative of the first, which is 1 times the inverse hyperbolic tangent of x plus x, and then I'm going to multiply by the derivative of the inverse hyperbolic tangent of x, which is 1 over 1 minus x squared. Okay? And then I'm going to add the derivative of this term. Well, I'm going to apply the chain rule. So I do 1 over the square root of 1 minus x squared, but I multiply by the derivative of the inside function. So I'll give myself room. So I'm going to multiply by the derivative of square root of 1 minus x squared. Just like this. So if we go to the next page, we get dy dx is inverse hyperbolic tangent of x plus x over 1 minus x squared plus I'm going to take 1 over the square root of 1 minus x squared, but I'm going to multiply by the derivative of that square root function. But you have to apply the chain rule. So it's going to look like this. It's going to look like 1 over 2 square root of 1 minus x squared, but I'm going to multiply by the derivative of the inside function, which is negative 2x. And again, that might be a little much, but it's chain rule that's getting me that piece. And so this is inverse hyperbolic tangent x plus x over 1 minus x squared. The 2's cancel if you notice, and square root of 1 minus x squared times square root of 1 minus x squared is 1 minus x squared. So it's minus x over 1 minus x squared. But these terms cancel, and you're left with the inverse hyperbolic tangent of x. And that was example 3. Let's take a look at one more example. We'll take a look at example 4 for this video. Suppose y is well, we can do this one. We can do inverse hyperbolic cosine of the square root of 1 plus x squared. And this is where x is positive. So the question is, what do we do with that? And so again, this is a really nice application of the chain rule. So when we take the derivative, we're going to get the following. We're going to get 1 over, so remember, we're taking the derivative of the outside function, evaluated at this inside function. So we get 1 over the square root of 1 plus x squared. So I'll say square root of 1 plus x squared, squared, and then I'm going to subtract 1. Okay? And then I'm going to multiply by the derivative of the inside function, which is square root of 1 plus x squared. If I go further, I get 1 over the square root of Now, when you take a square root and square it, you just get the value inside that radical, which is 1 plus x squared. And then I'm going to subtract 1. And then I'm going to multiply by 1 over 2 square root of 1 plus x squared times the derivative of the inside function, which in this case is 2x. So again, I'm going to talk about that in a minute, all right? Now, on the next line, notice how the 2's cancel, and we get dy dx is 1 over the square root of x squared times x over the square root of x over the square root of 1 plus x squared, right? Now, x is positive, and so this is 1 over x times x over the square root of 1 plus x squared. The x's cancel, and therefore dy dx is 1 over the square root of 1 plus x squared. Now, I want to make a note here to leave this video on. The derivative of square root of x is the same as the derivative of x to the 1/2, which is 1/2 x to the negative 1/2, okay? Now, remember that 1/2 x to the negative 1/2 is the same as 1 over 2x to the 1/2. But x to the 1/2 is the square root of x. So this is equal to 1 over 2 square root of x. So when you take the derivative of the square root function, I would hope people can get to a point where you can just write that down, because it's going to come up over and over and over again. Okay? So this is true. Now, if you want to apply this in a broader sense, so like let's say you want to take the derivative of x, the square root of x squared plus 1, you would get 1 over, now the outside function's that square root function, so it'll be 2 square root of, now the inside function is x squared plus 1, so I'm going to write that down. But I'm going to multiply by the derivative of x squared plus 1, which is 2x. 2's cancel, and you get x over the square root of x squared plus 1. So that's where that came from. And that'll conclude this video for section 3.11. This is on derivatives of inverse hyperbolic trigonometric functions. And I also did 4 additional examples. So, okay, thank you.